This video provides an introduction to graphing quadratic functions. A quadratic function is one that can be expressed by the equation f of x equals ax squared plus bx plus c, where a is not equal to 0. The graph of a quadratic function is called a parabola and has a U shape to it. Consider the graph of f of x equals x squared. The maximum or minimum point of a parabola is the vertex of the parabola. The vertex of our graph would be right here at the origin. The vertical line that passes through the vertex is called the axis of symmetry. Either side of the parabola is equidistant from this axis of symmetry. So, for instance, here at 3, y equals 3, our parabola is equidistant away from the axis of symmetry on either side. There are several observations that we can make about parabolas and their equations. Parabolas are always symmetric with respect to their axis of symmetry, which is the vertical line passing through the vertex. If the leading coefficient of your quadratic function is positive, then you know that the parabola opens up like this. If the leading coefficient is negative, then the parabola will open down. If the leading coefficient is greater than 1, then the parabola will be skinny and narrow. Something like this. And then lastly, if the leading coefficient is less than 1, and I'm not talking negative, I mean something between 0 and 1, a proper fraction, then the parabola is going to have a wide shape to it. That's nice to have in mind before you start graphing, so if your graph doesn't end up supporting what you know it should look like based off of the equation, you can more easily identify a mistake that was made. We're going to be graphing quadratic functions that are in general form. General form is f of x equals ax squared plus bx plus c. To find the vertex of a parabola in general form, the vertex is the ordered pair negative b over 2a comma f of negative b over 2a. So here I've outlined it more in steps how to find the vertex of a parabola. The first thing we're going to do is find the x-coordinate of the vertex using the formula x equals negative b over 2a. I always remember that this is the equation I need for graphing parabolas because it's the beginning part of the quadratic formula, right? X equals negative b plus or minus all this over 2a. So I just use my knowledge of quadratic formula to help me remember this formula as well. Once you get the x value, you're going to plug it into your function to get the corresponding y value. This will be the y-coordinate of the vertex, and then we'll write our vertex as an ordered pair. Let's practice identifying the vertex of each quadratic function. We have to start by finding the x-coordinate of the vertex. The x-coordinate is negative b divided by 2a. So that's going to be negative 8 over 2 times 1. That's positive 8 over 2, which is 4. The x-coordinate of our vertex will be 4. To get the corresponding y value, we're going to plug this x value of 4 into our function. F of 4 will be 4 squared minus 8 times 4 minus 1, which is 16 minus 32 minus 1. We get negative 17. Our vertex is the ordered pair for negative 17. Let's find the vertex for g of x equals negative 3x squared plus 18x plus 5. Again, we start by finding the x-coordinate of the vertex using our formula x equals negative b over 2a. That'll be negative 18 over 2 times negative 3. It's negative 18 over negative 6 to give us positive 3 as the x-coordinate of our vertex. We'll plug this back into our function to get the corresponding y value. We're looking for g of 3. Negative 3 times 3 squared plus 18 times 3 plus 5. It's going to be negative 3 times 9 plus 48 plus 5. Negative 27 plus 48 plus 5. The corresponding y value is positive 32. The vertex of this parabola is the ordered pair 3, 32. To find the x-intercept of a quadratic function, we're going to do what we've always done. We're going to let y be equal to 0 and solve for x. Note that with a quadratic function, you can get either 0, 1, or 2 x-intercepts. I'm going to draw you some pictures so that you can see why that makes sense that we have those 3 different options. We could have a parabola like this that is above the x-axis and opens up. It'll never hit the x-axis. This is going to have 0 x-intercepts. If the vertex of your parabola is on the x-axis, then you're going to have exactly 1 x-intercept. And the last option is our parabola could hit it twice. The vertex is on one side of the x-axis and the parabola is opening up in the other direction. To find the y-intercept, we'll do what we've always done. We'll let x be equal to 0 and solve for y. Remember that you need to write both the x and y-intercept as an ordered pair. The last thing I want to talk about in this introduction are symmetry points. We've discussed that parabolas are symmetric about their axis of symmetry. Well, symmetry points are points on either side of the axis of symmetry equidistant from the axis of symmetry. A symmetry point can be found by reflecting a known point on the graph. I typically like to use the y-intercept about the axis of symmetry. To graph a quadratic function, we're going to want to find and plot the vertex. We'll find and plot the x-intercepts. We'll find and plot the y-intercept. Once we have those points, we're going to use the axis of symmetry and the Y-intercept to find and plot a symmetry point. In the next video, we'll actually graph quadratic functions.